So this problem says a stereo manufacturer determines there's a lot of spelling errors in this. I really need to fix it. Determines that in order to sell X units of a new stereo, the price per unit is given by this function, this little p of x right here. And they also give us another function that tells us the cost. The very first thing it's asking us is to find the revenue. They obviously did not give it to us. And if you think about what revenue is, like if there is a candy bar that I'm selling and it's $1 and I sell 1 unit, then I make $1 or my revenue is $1. If you sell 2, then you get $2, right? So what revenue is, R of X is really equal to whatever the price of the item is multiplied by X units, okay? So we're given a P of X function, a little P of X function, so that's 1,000 minus X, and then we're going to multiply that by X to get 1,000 X minus X squared. So now it's asking me to find the profit. So profit, if you'll remember, profit is always equal to revenue minus cost. So I'm going to use that function that I just found for revenue, and I'm going to subtract cost from it. So that would be 1,000 x minus x squared, then subtracting our cost function up top. And once we combine like terms, get negative x squared plus 980x minus 3,000. So on part C, where it's asking how many units must we sell in order to maximize our profit, that maximum is going to occur at the critical x value. So it's saying the profit is maximized when or where. So it's looking for x value, an x value right there. Anyway, so I'm going to find that critical x value by taking the derivative of that profit function. And then setting that derivative equal to 0. And so that would be 490. So when 490 units are produced and sold. Now, to find out, so 490 units are produced, and that's when the maximum occurs. To find out what that maximum actually is, you would want to plug 490 back into your original function. Well, like what original function? We have a price function. We have a cost function. I ended up finding a revenue function. But we're looking for the maximum profit. So you plug it into the original profit function, okay, which is that negative x squared plus 980x minus 3,000. So let's see what we get. So I get $237,100 for that maximum profit. So let's figure out this sentence. The stereo manufacturer makes a maximum profit of that $237,100 By producing 490 stereos, this is redundant, what price per unit must be charged in order to make this a maximum profit? And that's like, well, have I already been asked that question? Wouldn't you just plug the 490 into the original function? Yes, but which original function, right? When earlier we plugged it into the original profit function because it was looking for a profit Y value. Well, now we're going to plug the we're going to plug that X value into the original price function since it's asking us what price per unit. So since it is maximized with 490 x's, we're just going to plug 490 in for x. So 1,000 minus 490 is 510. So this one's asking about the production level for maximum profit, and yet again we don't have a profit function. I'm going to have to find that profit function. Remember, profit is always revenue minus cost. So let's see what we get. So we get that negative 0.5x squared plus 3.6x minus 3 for that profit function. I'll just now take the derivative of that to get negative 1x plus 3.6, and we're going to set that equal to 0. So our critical x value happens at 3.6 units. And we're just going to plug that x value of 3.6 into that profit function. And it's going to give us our y value, our maximum profit. Again, it occurs at the x value of 3.6, but the profit itself, the maximum, and it doesn't say maximum here, but it is asking for profit. That is your y value. So P of 3.6. And I end up getting 3.48. So to finish this one out, the maximum profit of 3.48 happens when you produce 3.6 units. A clothing firm determines that in order to sell X suits, the price per suit must be 120 minus 0.75x. It is also determined that the total cost of producing these suits is given by this particular cost function right here of 2,000 plus 0.5x squared. So find total revenue. Well, remember, revenue equals x times whatever your price is. Okay, so the price, that 120 minus 0.75x, I'm just going to multiply it by x. So that revenue function comes out to be, oops, I didn't write it all the way right, 120x minus 0.75x squared. So what is the profit? The profit is always revenue minus the cost. So I'm going to take this new revenue function that I just found of 120x minus 0.75x squared, and I want to subtract cost from it, and they give us cost of 2,000 plus 0.5x squared. And I get negative 1.25x squared plus 120x's minus 2,000. So how many suits must we produce in order to sell a maximized profit? Well, we're just looking for that x value for the maximum, so it's going to happen at the critical x value. How do you find that critical X? Same way we've been doing it the last several problems. It's the same way every time. Take the derivative of that profit function to get negative 2.5x plus 120. We're going to then set it equal to 0. So x equals 48. So that's when the profit is maximized. So what is the maximum profit? Well, we're just going to plug 48 into the original profit function. And I'm saying P of 48, and I'm saying big P, not little p. Little p is the price, okay? So big P is always profit, little p is the price. And when we plug in 48, we get 880. That's that Y value, okay. So what price per suit must be charged in order to maximize profit? Well, we know when profit is maximized, it's at 48. And so we're going to plug that x value of 48 into now not the profit function. I just did that. That gave me what the maximum profit was. I'm going to plug 48 into the price function. So little p of 48. And that is what? 2,000 plus 0.5 times 48 squared to get 3,125. That's an expensive. Oops, I'm a little bit dyslexic. I wrote that down wrong. 3,152. There we go. Still, that's an expensive suit. So if the price charged for a bolt is P cents, then X thousand bolts will be sold in a certain hardware store where P, where price, is 57 minus X over 20. And this question's a little bit different. So appreciate the simplicity of all of that it's asking. It's just asking about the maximum revenue, not maximum profit. Didn't give me any sort of a profit function, just about maximum revenue. So that revenue function, again, is given to us by multiplying the price function by x. And so I did that right here. And notice when I distributed that x, I went ahead and called x over 20 times x. I called it 1 over 20x squared. Only because that's going to be easier to take the derivative, which I'm about to have to take. I'm about to have to find r prime, which is 57 minus 1 over 10x. And by writing that negative 120x squared the way I did, instead of calling it x squared over 120, it was easier for me to take that derivative. I got that derivative of 1 over 20x squared to be 1 over 10x because I said 2 times 1 over 20, which simplified to 1 over 10. And I got x because of, the power of n minus 1. So 2 minus 1 gave me that first power right there. Anyway, setting this equal to 0, we get, let's see, we get an x of 570. So let's read the question. Price charge bolt cents 1,000 will be sold hardware store where the price is how many bolts will give us the maximum revenue? 570.